Hello, greetings, and welcome. Let's take a look at our second integer programming problem from week 8 from chapter 4 of the course text. In this screencast, I'll set up our integer programming problem, and then we'll have a separate screencast in which I'll solve using LibreOffice Calc. So here we go. So Jabico is planning to produce at least 2,000 widgets on 3 machines. The minimum lot size on any machine is 500 widgets. The following table gives the pertinent data of the situation. So we're given information for machine 1, 2, and 3, the setup cost of each machine, so that's going to be a fixed cost if we're going to use each of those machines. The production cost, in terms production cost per unit in dollars, and capacity of each machine. And we're asked to formulate the problem as an integer programming problem and find the optimal solution. Alright, so this seems like a fun one. And it's just going to be a matter of going step by step. Okay, so what's my ultimate goal going to be? Right, my ultimate goal or my objective is going to be to minimize our cost. Alright, so we want to minimize our costs. Okay. And what are our costs composed of? Right, our costs are going to be composed of our production costs on a per unit basis, but then our costs will also be made up of the setup cost of each machine. Alright, so if we're going to make widgets on machine 1, there's going to be a fixed cost of setting up that machine, and then we'll incur a per unit cost for each unit produced on that machine. Okay. And so before I write down my objective function, then, knowing that this is going to be my objective and here's what's going to go into it, we're going to define our variables. Okay, and so I'm going to create two sets of variables. Okay, so set 1 is we're going to let x1, x2, and x3 be our standard number of, in this case, widgets, or I'll just say number of units made on each machine. Okay, so I'll have a variable for the number of units made on each machine, because for each unit made on unit 1, say I'm going to have a production cost of $2. All right. And then the other variables I'm going to introduce is y1, y2, and y3, and this is going to be 1 if my machine is used, okay, and 0 if not. Okay, so when I think about my objective function, I can take my setup costs of each machine type and multiply by y1, then y2, and y3, so that if I'm going to use that machine, I need to account for the setup costs, but if I'm not going to use the machine, then there's going to be no setup costs because I'm not using that machine. Okay, and we'll flush this out more once we set up our problem. Okay, so now that I have my variables defined, and now I'm going to go back to define my objective function. Okay, so I'm going to define my objective z. Okay, so our goal is to minimize our cost. Okay, and so z is going to be associated with the cost of setting up each type of machine. Okay, so we'll have 300 times y1 plus 100 y2 plus 200 y3. Okay, so here's the cost, and so this is in dollars of setting up each type of machine. Remember, our y's are going to have values of 1 or 0, 1 if we're using the machine, 0 if not. Okay, so that's our cost of setting up our machines, plus we're going to have our per unit production cost. Okay, so on machine 1, it cost me $2 per unit. Okay, so we're going to have 2x1 plus on machine 2, it's 10x2. On unit 3, we're going to have 5x3. Okay, we want to minimize that. Okay, cool. Now, before we move on, okay, you might be looking at this and saying, maybe I'd like to take these quantities and multiply by y, right? Y, because if I'm not using a machine, I multiply by 0, then I take that contribution from my objective function. Okay, but we're not going to do that, right? Because then, that could still allow the possibility of x1 being non-zero. It would just get assigned a weight of 0 my objective function, which wouldn't be fully right. Okay, and so we'll account for the fact that if y1 is equal to 0, x1 must also be equal to 0 within our constraints. Okay, and so again, we'll piece this together piece by piece. Okay, so first there's my objective. Okay, cool. So now let's go piece by piece. So first, we're planning to produce at least 2,000 widgets. Okay, so if we go through our constraints, okay, we want to produce at least 2,000 widgets. So that means x1 plus x2 plus x3 needs to be less than or equal to, or greater than or equal to 2,000. Okay. The minimum lot size on any machine is 500. Okay, so that's going to be the minimum lot size if a machine is used. Okay, so if a machine is used, the minimum lot size is going to be 500. Okay, and before we tackle that, on each machine we're given a capacity. Okay, so let's go through and formulate this animal. Okay, so on machine 1 I have a capacity of 600. Okay, so if I was to write this down, okay, the first thought would be x1 is less than or equal to 600. Okay, that'd be my first thought of how I would write down this capacity, right? x1 is less than or equal to 600. Okay, but this is where I'm going to take into account my variables y. Okay. So the maximum number of units on machine 1 that I can create is going to be 600. Okay, but what I'm going to do is I'm going to multiply that by y1. Okay, why am I going to multiply by y1? Well, if machine 1 is used, then y1 has a value of 1, so that makes sure that if I'm using machine 1, I could produce at most 600 widgets on it. But now if I'm not using machine 1, y1 is going to have a value of 0, so this constraint reduces to x1 is less than or equal to 0, which can only be satisfied by x1 is equal to 0 when I enforce my non-negativity constraint. Okay, so here's where I get that if y1 is equal to 0, x1 will also be equal to 0. Okay, and I'm going to write that down for all my others, right? Something similar. So x2 is going to be less than or equal to the capacity 800. Okay. And I'm going to multiply by y2 so that when machine 2 isn't used, it forces x2, right? The only value of x2 that'll satisfy that relationship is 0. And I'm going to have x3 is less than or equal to 1200. Okay, its capacity also times y3 then. Okay, now I also need to enforce that the minimum lot size on any machine is 500. Okay, so this is going to be similar. Okay, and so I'm going to write them over here. So x1 is going to be greater than or equal to 500 times y1. So if machine 1 is used, okay, the value of x1 needs to be between 600 and 500. Okay, but if machine 1 is not used, then x1 is going to be equal to 0, right? Because 0 would be the only value of x1 that would satisfy either one of these or both of these inequalities. So I'm going to have x2 is greater than or equal to 500 times y2, and x3 is greater than or equal to 500 times y3, right? Pretty cool, right? Okay, and that's it in terms of constraints that we're given. So I have my objective function. I have our constraints. Okay, we have a couple more. Okay, so we're going to have non-negativity. Okay, so now I'm going to write down my standard constraints. So I'm going to have my non-negativity constraint. So we're going to have x1, x2, x3, y1, y2, and y3 are all greater than or equal to 0. Okay, I'm going to have my integer constraint. Okay, so all of my variables are going to be integers. Okay. So for x1 through x3, it makes sense. I can only make integer number of widgets, and then y1, y2, and y3, again, we said will only take on values of 0 and 1. Okay. Now, how do we deal with that last part? So y1, y2, and y3 are either going to be 0 or 1. Okay, so what that would mean is, okay, in general, I'd have 0 is less than or equal to yi is less than or equal to 1. Okay, so since yi is integer, this inequality will only be satisfied by if y is equal to 0 or y is equal to 1. Right, so that's how you get y is equal to 0 or y is equal to 1. I'm already applying non-negativity, so I'm already requiring that y1, y2, and y3 are greater than or equal to 0. Okay, so how I get this to work is I'll apply the constraint y1, y2, and y3 are all less than or equal to 1. Okay, so that y1, y2, and y3 can only take on values of 1. Okay, so that's it. Okay, that's our integer programming model. So we're going to minimize our cost. Here's our constraints. Here we have this unique feature that we're taking our capacities and minimum run quantities and multiplying by this binary variable determining if a machine's used or not. Non-negativity, so our standard non-negativity constraint. Integer programming, now we're applying this integer constraint. We're going to assume that all of our variables are integers. And then our y's are less than or equal to 1, which will fix it so that y can only be 0 or 1. Okay, hope that helps. I'll go over next into LibreOffice and solve the problem.